So I've got here f of x equals the square root of x plus 1, and we're asked then to find the expression for the inverse function of f. So the first thing to do, of course, you just write f of x as y, because that's what f of x is. And then we're going to rearrange this then, okay, to get it in terms of, to get x in terms of all the other values here, okay. So if I take that square root over, okay, it'll become y squared, yeah, because when you take a square root over, you do the opposite. So the opposite of square rooting is squaring. So we square that side. Okay, no need to worry about plus or minus this time because we're not square rooting. We're squaring. So we take it over and then we get x plus 1 here. And then all you've got to do, of course, then is take that 1 over and you get your inverse function. Okay, so that's how you get back to the x values by doing y squared minus 1. So we write this then as a proper function. So we put it in terms of x and we're sorted. So then, in B, we're asked to find the domain and range of f inverse. But remember, of course, we must first of all think about f of x, what its domain and range is. So its domain is 0, infinity. That's given in the question. And its range, well, if we put 0 in there, okay, so f of 0 will be 0 plus 1, and then square rooted. So that'll just be the square root of 1, which is 1, okay? And then if I put infinity in there, well, infinity plus 1 is still going to be infinity. And if you square root infinity, it doesn't matter because it's still infinity, okay? So we've got 1 infinity there for our range. So for f inverse function, of course, we remember then that they just flip around. So the domain will just be the range that we had for f, and the range of f inverse will be the domain of f. Okay, it really is that simple. We're then asked to sketch f to minus 1 of x using the same diagram, sketch the graph of y equals f of x. This is interesting this time because they're asking us to sketch this function first. Okay, and if you think about it, it's actually easier to draw this, isn't it? Because you know what that looks like. You know what that looks like. And f of x, maybe you're not so sure what it looks like. So they're getting you to draw this first. They're helping you in a way. So what I'm going to do, okay, a couple of things here to start with. I'm going to first of all think about what x squared minus 1 looks like. Okay. Now x squared minus 1, if you think about it, is a smiley face, but shifted down 1, yeah? So it's going to be this. Now I'm not obviously going to draw it restricted to that domain for the minute. I'm just going to consider what x squared minus 1 looks like for the whole of the real numbers, okay? But the domain is restricted, okay? Which of course we want the domain to be restricted because we need it to be 1 to 1, as we mentioned before, and the domain is restricted from 1 to infinity. So it's actually from here all the way to infinity. So that's what f inverse x will be, f to the minus 1 of x will be. It'll just be this bit here because the domain starts at 1. And of course, when you put 1 in there, you get 1 squared minus 1 is 0 in the range. So that point there is the right point. So we can ignore this bit of the curve, okay? So when I actually then do my final answer down here, okay, I'm just going to draw this bit here. So that sometimes helps. Draw the whole thing for you to see which bit you need. And then we'll go from here. Draw that, so we get x squared minus 1, and that's, I'll write that, of course I'll put f of minus 1x as well there. Now of course to draw f of x then, remember it's a reflection in the line y equals x, okay, so you just need to remember that always that's the case. The inverse function will be reflected in the line y equals x. So if we've drawn f inverse x first, the inverse function of f first, then we can draw the f of x just by reflecting it. Now, the other thing I should do here is write 1 there. So when I reflect it, it's gonna cut that 1 as well, isn't it, on the y-axis? Okay. And what happens is, of course, is that it sort of curves into the mirror. Okay, so it gets closer to the mirror and then starts to curve away. Okay, so you kind of get that effect there. Okay, just like that there. Okay, and it does get further away from the mirror, so maybe I should have that increasing there. Okay, we don't want it going down closer to the x-axis, and we're done.